Hey, welcome back to your favorite intermediate algebra class. Good to see you today. We're going to talk about solving linear systems algebraically. So that's our objective, is to use some algebraic methods to solve some linear systems, such as the first one here is the substitution method, it's called. And the second one is called the elimination or linear combination method. So let's go ahead and solve this first one here. Use the substitution method. You can see those steps listed there. So the first step is we're going to solve one of the equations for one of its variables. So I'm looking at these x's and y's, and I like to pick the easiest variable. In other words, a variable that has a coefficient of 1. So you see that x right there? That's the equation and the variable that I'm going to pick. So solve for one variable. So I pick an equation, solve for one of the variables, and I got x equals 2y plus 4, okay? So what I'm going to do now is I'm going to plug that into my other equation, because what I'm looking for, so step 2, substitute into the other equation, okay? So here's the other equation, 2x minus 3y equals 1. And I go ahead and I plug that x value in there. So 2 times, now I got this new x value, because you notice x is equal to 2y plus 4, so that's going to go right there. 2y plus 4 goes in for x. And now you notice we have one equation here and only one variable. I'm just left with y's. Okay, so this now becomes solvable for y. 4y plus 8 minus 3y equals 1. Combine any like terms I got. 4y minus 3y is 1y. 8 plus y equals 1, and I go ahead and subtract 8 here. So now I know my y value, negative 7. Oops, didn't draw that very well. Negative 7. Last step, number 3. Now I know y equals negative 7, and I can substitute into either of the original, either equation. Okay, so I'm going to pick, you know what, let me go back to the original. X minus 2y equals 4. X minus 2 times that y value, x plus 14 equals 4. Okay, subtract 14. There you go. So x equals negative 10. There's our final solution. X equals negative 10. Y equals negative 7. There's our x, y. There's our ordered pair. So in other words, these two lines, graphically speaking, we talked about a graphical solution last time. These two lines cross at that point, negative 10, negative 7. Okay, so that's substitution. You solve for one of the variables, plug it into the other equation, solve it for the variable, plug it into either of the originals, and you have it. Okay, so that's a review of your substitution. Now the other one is called linear combination, or the elimination method. Okay, I like the elimination method because that's telling you what you're going to do here. So you're gonna eliminate one of the variables. Okay, so step 1. I'm looking at these two equations. You see this 2x minus 3, whoops, 2x minus 3y equals 1. I got this other one, 4x plus 2y equals 6. So I'm looking at which variable, if I was to add these up right now, if I was to add these up, what would I get? 2x minus 4x, I get negative 2x. Negative 3y plus the 2y right below it, I'd have negative y. And I say, well, if I added them, one of the variables does not eliminate. What I'm trying to do is eliminate one of the variables when I add them so that I can solve for the other variable, okay? So let's get rid of, how about we get rid of the x's? You notice the negative 4x and the 2x above it, okay? What's their least common multiple? And you say, well, 4. So if I was to add these up, right now I have negative 4x. What would this have to be so that they would, you know, have a difference and subtract out, add out, I should say. And I say, well, the 2x needs to be a 4x. It needs to be a 4x, so I have 4x minus 4x, and then it's gone. Okay, so I want them to add up and eliminate a variable. So I say, I'm going to multiply this then by 2. And what would I then have? If I distribute that through, that's what it would become. The bottom one stays the same, negative 4x. And now you notice when I add them up, so step 1 is multiply it by a constant to make sure that one of them eliminates when you add them up. So you notice I have 4x minus 4x, that's gone. Now I'm doing this one, negative 6y plus 2y is negative 4y. 2 plus that 6 is 8. Okay, divide by negative 4, both sides here. You say, oh good, y is negative 2. Okay, y is negative 2. Now I know. Okay, now I know, so step 1 was multiply it by a variable. Step 2, add those equations right there. Step 3, now I solve that thing. So I know that y equals negative 2. Now I just substitute it in. So I pick one of the original equations. Let me pick that top one, 2x minus 3y equals 1. Plug my y in. So 2x plus 6 equals 1. 2x equals negative 5, divide by 2. Okay, so it looks like we got it. Our answer, x, comma, y. Negative 5 halves, comma, negative 2. Okay, so that's how you do the elimination process here. Let's do another one. Let's do another one here. How about move this over a little bit. 2x plus 5y equals 6, 3x minus 2y equals 2. Okay, let's say you notice again, right now, if I was to add these things up, 2x minus 3x negative x, 5y minus 2y is a positive 3y, and I get an 8, right? So I'm like, okay, one of the variables does not naturally eliminate given what I have, so I have to force it. Step 1. So I say, you know what? Let me get rid of the y's. Okay, what's the least common multiple of 5 and 2? And you say, well, it's 10. It's 10, so I need the top one. If I multiply this by 2, I would get, when I multiply that through, I would have a 10y, wouldn't I? I'd have 4x, I'd have a positive 10y, I have a 12, right? Which means the bottom needs to be, if I'm to eliminate it, it needs to be a negative 10y so that I eliminate y because I'm choosing y to eliminate here. So what do I need to multiply negative 2 by to get negative 10? I say, well, just a 5, because 5 times negative 2 gives me that negative 10y. Okay, so let's multiply the 5 through. 5 times negative 3x, negative 15x. 5 times the negative 2y, negative 10y, I already got that written. 5 times 2 is 10. Now we add these things up. 4 minus 15, negative 9x. 10y minus 10y, that's gone. That's the whole idea there. Equals 22. So negative 9x equals 22. Divide by that negative 9, and it looks like we get our solution here. Divide by, oh my gosh, you know what? Just kidding about that. 4x minus 5x, sorry about that. Negative 11x. Now I divide by negative 11. So I got the negative 2 there. Okay. Step 3. Now I know that x is negative 2. Okay. Go ahead and plug it into either of the original. I'm just going to pick the top one there. 2 times, now I know my x. Solve that thing. Add 4 both sides. Divide by 5. There's our y. So x, comma, y. That's the point where those two lines cross. Okay. Now you've noticed so far I've only had these points, these two lines. We've solved them algebraically, and they've always crossed, right? At one point, I had one solution, one ordered pair. What would happen algebraically if I'm solving these things? how do I know if I get infinitely many solutions, so they're the exact same line, or no solution? So let's give you an example here. Let's do this first one. 4x minus 2y equals 5, 2x minus y equals 3. You know what? Let's solve this one by substitution. Let's go back to that. So I'm looking at this variable right there. I'm like, you know, y, that coefficient's -1. So that y is going to be pretty easy to solve for. Solve for a variable. I'm picking this one. Okay. Solve for y. 5 by -1. 2x minus 3. Okay, now that's going to be substituted in to the other equation. So let's take the 4x minus 2y equals 5, and this y value, if you will, 2x minus 3 is going to go in right there, right there. Okay, so 4x minus 2 times that y equals 5, because y is equal to 2x minus 3. Now we go ahead and solve this thing. Notice the x's cancel. Uh-oh. And I'm left with 6 equaling 5. So that's the question. So what's going to happen here is your variables are going to cancel once you get to this step in substitution, or in elimination once you add them up. Variables cancel and you'll be left with a statement with these constants here. And you say, well, is this true or false? Does 6 really equal 5? You say, no, it never does. So these things are actually parallel lines. There's no solution there. Okay, they do not cross. They do not cross. In fact, if you were to solve this, you know how 2x minus y equals 3 is right there, right? Y equals 2x minus 3. Well, how do I know that they never cross? Well, let's just find out if they're parallel lines here. -2y equals -4x plus 5. Divide by -2, and I got 2x minus 5 halves. You see how they both have the same slope right there, slope of 2, but different y-intercepts. So these things do not cross. Okay, but algebraically, you get to that point 6, does that equal 5? You say, no way. Now, if you got to this point and it said like 7 equals 7, you say, yeah, sure it does. That means they agree at every point, and I would have said infinitely many solutions. Infinitely many solutions. Okay. So let's do one more here. All right, let's do this one by elimination now. -3x plus 6y equals 9, 4x minus 8y equals -12. Why don't we get rid of, let's use elimination, let's get rid of the x's. So I'm looking at the -3x and the positive 4x, and I say that least common multiple is 12. So why don't we multiply the top by 4? And you notice I would have -12x. So I need the bottom one to become a positive, I need it to become a positive 12x. Okay, so what do I multiply by? Well, it's already positive 4x, so I just need to multiply by a positive 3. And that'll give me a positive 12x. And then those things are going to cancel, aren't they? Okay, let's go through the rest here. Let's distribute that 4 through 4 times. Excuse me, sorry about that. 4 times -3 is -12x. 4 times 6y, 24y. 4 times that, 9, 36. Let's go now multiply the 3 through to each of those on the bottom. And now we add them up. I said -12x plus 12x, gone. 24y minus 24, gone. So what am I left with on the left-hand side? I just have 0. And then I have 36 minus 36. Guess what? That's 0. Does 0 really equal 0? I say, you bet it does. True. Infinitely many solutions. These things are the exact same line. So they cross at infinitely many points. And if you were to think about that, let's see if they are. Let's add 3x. Let's divide by 6. There's the first Negative 3x plus 6y equals 9. Let's do the other one. 4x minus 8y equals negative 12. Subtract 4x. Divide by negative 8. There's your half x. There's your positive 3 halves. Look at that. Same line, isn't it? Same line. Okay, but that's how you do it algebraically. You get to that point, if you have a true, a couple of constants there and they're equivalent, infinitely many solutions. Okay? All right, thanks for watching, you guys. Bring your notes and questions to class.